Hey there, everybody. Welcome back. So we've looked at doing some line integrals along the whole arc length. But what if we want to just integrate with respect to one variable, like along X or Y or Z? This does happen quite a bit, as you'll see the rest of the semester. But how do we address that? If we're not integrating with respect to Y or Z, then dy dt is 0 and dz dt is 0. So we just have ds as dx. And if we're parameterizing that with t, we've got x prime and t dt. If you stick that into your square root thingy, that's me being a champion right there. And the rest are zeros. That just gets you dx dt. So dx will be turning into x prime and t dt. And that makes a function like this. We can do the same thing with any of them. So if we go along y or z, we have y prime and t dt or z prime and t dt, depending on if we're doing dy or dz. And so if we have a couple, like we're doing, like if we got a function in one direction along x and a different function along y, we can do the integrals like this. And of course, obviously, addition with integrals separates them just fine. And it'll turn into something like that. So f of xy with respect to t times x prime of t dt, and then the same thing with y prime of t for the dy. The ab will stay the same because that's the limits of integration on the contour. The t equals a to t equals b. There is one caveat that we will explore in the next video. ds was with respect to the arc length, and orientation did not matter. Does this change if we just look at respect to one variable? Let's explore this through an example in the next video. Peace.